All right, guys, I threw a sequence up on the board. Anything special about it? It's arithmetic, right? Arithmetic, whatever you're going to call it. How do I know that? How do I know it's that special type? Because what am I doing every time? Adding the same number, right? And what is that number? 6. I call that the common difference, right? That's the D value. All right, now, and this is what we're going to have to be able to do today here for me. Write a formula for the nth term. All right, a general formula, all right, called the explicit formula. So we have a formula on our formula sheet that we're going to use every time we deal with an arithmetic sequence. Okay, that's where we live if it's arithmetic. If I'm looking for a formula for the nth term, I don't plug anything in for n, right? I just leave it. So this is going to stay a with a subscript of n. What's going in for a1? What's going in for n? Good, thank you. N minus 1 times 6. Now, some of you guys on your group assignment left it like that. That's fine. It's correct. I personally would like to clean it up, though. What do I do with the 6? So I have a subscript n equals 3 plus, keep going, through 6n, 6, and I'd like you to keep going even more. What do I end up with? 6n
minus 3.
Okay. That is the formula for this. Now look how powerful this is. Hey, you want to find, let's pick the 4th term. Let's find the 4th term. What do I plug in for n? 4. Watch. 6 times 4. Oh boy. 24 minus 3. That's how that term, that's an explicit formula right there, nth term. All right, you guys, I need you to have the ability to do that to be successful today. All right, given an arithmetic sequence, write a formula for the nth term. Anything here? Okay, before I get into the notes, actually, here's what I'm going to do today. I'm going to take this sequence. And we're going to start adding the terms. And you're going to tell me what they all add up to. But instead of saying, what do they all add up to? What do they all add up to? Where there's a word here we're going to use today. This word right here. Series. A series is when you add terms of a sequence, okay? So you're going to hear me say that word series. All I'm looking for, take the terms of the sequence and add them up and let me know what they add up to. Okay, we're ready to go here. Everyone got a graphing calculator? If you don't, make sure you got one in front of you because it is a must today. Must have. All right, let's do this. I already described what a series was. First thing is, where do I get these terms to add up? All right, where do I get these terms to add up? I want to introduce to you a Greek symbol right here called sigma. That's a Greek letter in the alphabet. Looks like an E, right? That tells me I'm adding sum, right? Sum. It tells me I'm going to add the terms. Now, how do I, like, I got this garbage on the bottom, this on top, this on the side. How do I deal with all these? These 3 things will get you the terms in the sequence we're going to add up. Do you see how it has a K in it? And you see how the bottom says K equals? That's where we start. We start by plugging in 3 for K. And you guys are going to get me the first term in that sequence now. So I take 3, plug it in for K. 2 times 3 plus 1. What's the first term?
7.
7. Good. So you've noticed what the first term is. 7. How do I get more terms? I plug in every number from 3 to 8 in for K. So we just plugged in 3, right? And everyone's all right how we got out the 7. Now I plug in 4 for K. Go ahead, plug in 4 for K. And what term do I get out? 2 times 4 plus 1? 9. I plugged in 3 and got 7. I plugged in 4 and got 9. Now I'll plug in 5. So go ahead real quick, plug in 5 and you end up with 11. When do I stop plugging in? when I get to the top number 8. Okay, so let's see, what have I plugged in? 3, 4, 5, plug in 6. And we end up with 13. 2 more. Plug in 7. 15. And then finally plug in 8. 16, 17. So here's my sequence. 7, 9, 11, 13, 15, 17. But today, the sigma says my answer is going to be those terms added up. A series. All right? Those terms added up. And that's going to be my final answer here. And we add them up. Ends up being 72.
Oh, I didn't. Wait, no, so
72. We're all good. Okay, so that's what the sigma says, and that's what a series is when I add up terms in a sequence. One doesn't make us great. We're ready to move on? All right, next one. Here's the next one. Now instead of K, I have N. What do I start plugging in for N? At the bottom. So everywhere I see an N, I plug in 0. So just type it as is on your calculator. 2 times 3 in parentheses raised to the 0. And could somebody get me my first term here? Let's start calling on people here instead of the shout out method. When you plug in 0, what do we end up with? 4. Here we go. Marnie, what do we end up with when we plug in 0?
2.
2. Good. So 2. Now what should I be plugging in everyone in for N?
2.
I just plugged in 0. Now I plug in every number from 0 to 4. So, all right, go ahead, plug in 1. What's the next term here? 14, Isabel? 6, good job. And if you want to start doing it, you know you're going to add them up along the way, so put in that plus sign. All right, I plugged in 0, 1. Go ahead, plug in 2 now. 2. Paige, when you're ready.
Give me a second.
Yep, I plugged in 0 and 1. Now I'm plugging in 2.
Yeah, I was a little bit behind.
All right, we're good. Now we're caught up.
64. Wrong? 54.
I plugged in 0. I plugged in 1. Now I'm plugging in 2 for N. So 2 times 3 squared.
Oh, I put 4 in front. Okay. So 36. What? Just explain to me real quick because I'm confused.
Okay, we start by plugging in the bottom number, which is 0, right?
Yeah.
I do 2 times 3 to the 0, which was 2.
2 times 3. Oh, you do 3 to the 0 first.
Or you just type it all in your calculator. It should be fine. But yes, you would do 3 to the 0 first.
Oh.
So now I'm looking to plug in the number 2 and see what comes out.
Now somebody said something else, so I don't even want. Can you just call on somebody else?
We're fine. 2 times 3 to the second. That's all I'm looking
18.
for.
Somebody said 52, so I'm a little bit.
So we got 18. Here we go.
Oh, it is 18. Okay.
Let's move on now. Ready? Plug in 3 now for me. Plug in 3. What do I end up with? 13. Richie? 54. Looks good to me. And now I plug in finally 4 into there. And I end up with Richie again. $1.62, right? And now all I need is add those bad boys up. And that's my answer. Richie, 3 for 3. Unbelievable.
I need to do this.
Okay, you do that.
$2.42.
Yes. What that sequence adds up to. Good. Any questions? Ask now. We're all good. What is the change to number 3? What's different from number 3 than 1 and 2? Real simple one, Kate.
There's a number up front.
There's a 2 plus, right? All that is at the end, I'm going to add 2 to my answer. Not 2 to every term. 2 to my answer. So whatever I find the sum to be here, I'm going to add 2 at the end. Everyone clear? Not 2 to every term. 2 to the sum at the end. So let's worry about the sigma here. All right, what number do I plug in for n first? 1. Good. So somebody plug in 1 and let me know what we end up with. 5. Emma?
10.
10. Plus, now that was plugging in 1. Now we plug in 2. Let's go quick now. Plug in 2 and we end up with Richie. Here we go. I plugged in 1 and got 10.
Oh, 7.
10, 7, good. Now I'm plugging in 3, everyone. I'm plugging in 3 for n. 9, Harper.
6. Wait, pause. Wait, which one are we on?
I plugged in 1 and got 10, plugged in 2 and got 7. Now I'm not plugging in 3 for n.
6, right?
13 minus 9.
Yeah. Oh, wait, 4, but then plus 2.
Oh, no. Look. The 2 is added after I add everything up. It's not added to every term. Okay, this just says add 2 to the sum. Okay, so I'm finding the sum now, and then I'll add 2.
To sum of each one.
No, just the sum altogether. All right?
Wait, how'd you get 7 again?
How did I get 7? 3 times 2 gives me 6. 13 minus 6 gives you that 7.
Okay.
We all good? All right, so I need to plug in 4 now, right? Everyone good? We're got 4 now on tap. Okay, so plug in 4, and we end up with what term? 14, Isabel, go ahead.
1.
What do I got? 1. Yes, I got 1 there. And now if you want, I can put that 2 right there. You can find out what 10 plus 7 plus 4 plus 1 is, then add 2. But the 2's got to get added sooner or later. And this final series answer here ends up being, take your time when you're ready, 5, Emma?
24.
24. Perfect. Any questions? Okay, let's stop for a second. I guess I'm sorry. All right.
Oh.
I needed you guys to understand how to do this by hand. All right, because you'll have to do it in a minute by hand. But you have a sigma button on your calculator. Does it all for you. Okay? Does it all for you. So go to your calculator. Alpha window. And I'm hoping your calculators are updated. Alpha, if you borrowed one of my calculators, there's a chance that it might not be, and I need to update it. But alpha window. Everyone see number 2? Is there a sigma button? Sorry, Max. Sorry. So go ahead, number 2, and look what pops up. You just have to input everything you need to. All right, so this one involves what? K? Now look, do you have to use a K? No, if you want to keep it X, just make sure it's X all the way through. All right, I'll keep this one K. So K right above your parenthesis equals 3. All the way up to 5. And then inside the parenthesis, I'm going to go K. So if you're using K, you got to hit your alpha button. Alpha parenthesis squared plus K. And we'll just do all the work for you. There it is. So I don't need to see any work anymore. 62.
How is it K minus X? Oh.
Whoa. Oh, we're talking about the next one. Yeah, we're not even there yet. Don't start sniffing the next one here yet.
I'm just confused with the bottom one. Is that a minus?
Here, this is K equals 2.
Okay.
Yep, this is K equals 2. Sorry. Okay, Before I get into this one, this is a whole different beast. Is everyone all right now on the calculator that I can do this? But there's a but though. You can't do it for everything. You can only do it if it has a single variable. Notice in the next one, what do I have? 2. So your calculator can't handle that. That's why I need you to know how to do this by hand. Okay, because your calculator will only do anything that's got a single variable, not doubles like this one. All right, but we know how to do this, right? What are we plugging in for? Which one of the two variables, k or x? K, all right, stay with me. I'm going to go slow. So we're going to add 4 at the end, all right? Not add 4 to every term, just add 4 to the end. So if I plug in 2 for k right now, what do you have to do to that 3? Distribute, right? So it'll be, ready? 6 minus 3x. There's your first term. Everyone all right on how I got that? I plugged in 2 for k and distributed. I know I got to add 4 at the end. I'll put it down there at the end. All right, now I plugged in 2. What do I plug in now? 3. And still distribute 3, right? So what's term number 2? 9 minus 3x. So I just plugged in 2. I plugged in 3. Next one. Plug in 4 for k. Distribute. And what's my next term now? 12 minus 3x. All right, one more to plug in, right? And that's 5. So what are we looking at here? 15 minus 3x. And don't forget, what do we still have to add to all this? The 4, right? So I'll put that in now. We've got to add in the 4. And then now you take your darn time and combine all your like terms. And hopefully it's one of the multiple choices we have up there, huh? (46 minus 12x). Quick question, because I know this is going to come up in the future and I want you to be prepared for it. Say I got rid of that plus and just left the 4 next to it. What do you think I want you to do to your sum now? Multiply it by 4, correct. Still, we're not multiplying every term by 4, just the answer by 4, correct. Good. All right, I think there's one more here. How many variables in this one? 2, so don't bother using your calculator or your sigma button anyway. All right, which variable are we plugging in for?
0
For x, right? We're going to plug in for x. So let's plug in 0 for x right now. So I have 3 minus 2a all raised to the, remember your exponent rules? And it doesn't matter what I raise to the 0, answer's always. So guess what? There's your first term, 1. Done. So I just plugged in 0 for x. Now what do you want me to plug in? 1, okay. That's not bad either, right? 3 minus 2a to the first will just be? So add 3 minus 2a. We're moving. Now we got to do a little work. Finally, I got to plug in what for x? I plugged in 0 and 1. Now I got to plug in 2. Here we go. Buckle up. Don't you dare try to distribute that 2. It's not 3 squared, 2a squared. Come on, you're better than that. How many times is this occurring? Twice, right? So maybe off to the side, 3 minus 2a times 3 minus 2a. Yep, that's what that is right there when I square it. All right, how's your foiling double distribute game, huh?
Wait,
What?
couldn't you just, if it was, couldn't you just do
minus 2a squared.
Oh, no, watch. It's not going to happen. Watch when we do this one. Ready? Yeah, I get the 9, right? But watch. Isn't this minus 6a?
Yeah, but
Are those going to cancel? No. That's why I just can't apply the 2 to each of these, because the middle term's not going to cancel. Okay? And then over here, what do I get? Negative 2a times negative 2a? Oh, boy.
Negative 12.
Positive 4a squared. You can keep it like that. You want to simplify it before you put it back in. It's up to you. So plus 9 minus 6a minus 6a. Okay, that's what I ended up with. So now combine all your like terms and see which multiple choice we have.
Oh.
There's a lot to combine, right? Take your time. Choice 4. So we can move on. Choice 4. Anything here? Hey, all right, now we get a little fired up here. Now we know how to handle the sigma. Maybe if it's got one variable, I use my calculator. If it's got 2, I know how to do it by hand, and we're all comfortable doing that. Now, why am I showing you all this sigma business? Because you guys have to build it on your own now. You have to build your own sigma, type it in your calculator, and tell me the answer. First, look at the numbers in my sequence here. 12, 19, 26. See any pattern there? What's the pattern here? 12, 19, 26. Add 7. So this is arithmetic. This is arithmetic. Everyone agrees? Here's what it looked like. 12, 19, 26. Keep the pattern rolling all the way up to 180. But now, I want to know what all those add up to. So anytime you're going to add terms in an arithmetic sequence, you need to build your own sigma and type it in your calculator. All right? So again, if I ever ask you to add up terms in an arithmetic sequence, you have to build your own sigma to find it. Ooh, how are we going to build this? This will be fun, huh? I'll make it easy on you. We always start by plugging in 1. So the bottom, always n equals 1. We'll always start there because my rules work from there. What should we place here? To the right? That's the equation of the nth term that I started class off with today. 12, 19, 26, all the way up to 180. I want to come up with a rule. The same rule, where is it? How I did it for this one. Okay? So formula from the formula sheet. We're going to do this off to the side. I'm trying to make a rule for the nth term for this sequence. So all I'm doing is getting that formula we've been using off the formula sheet. What am I plugging in for n?
4.
Oh, boy.
Why would it not be 4? 1, 2, 3.
If I'm looking for an equation for the nth term, n stays n.
Oh, I was
Right? All right, let's go. First term. What do I plug in for this n? Nothing. N minus 1. And what did you say I was going by, the d value? 7. Good. Now clean this up. What do I do with the 7? Distribute. 12 plus, keep going with me, 7n minus 7. So it ends up being 5 plus 7n, 7n plus 5. Now, there it is. That's what I plug in here. I'm missing one value though, aren't I? What do I got to plug in from 1 to, I got to find that top value now. I just can't add up as many terms as I want. It's got to stop at what? 180. So I need your help figuring out 180 is the what term of this sequence. Is it the 8th, the 9th, the 20th? That's what we need to figure out because that number is going to go up here. Where is 180 in the sequence and how we're going to do it? You did the hard work already. Let's use this darn formula. What's a sub n usually mean to us? Any term. What are we trying to find the position of? Which term? 100n? So where does 180 fall here? Okay, so whatever term you're trying to find its position, plug it in for any term, and now solve for n. And that'll tell you where 180 falls in the sequence. And you end up with, where does it fall? So it's the 25th term, right? So we're going to plug in every number from 1 to 25. And I am not letting you do, don't look shocked at me. I'm not asking you to do it by hand. Everyone's got a calculator where I showed you it does it like that. All right, I wouldn't do that to you. Alpha window. If you want to use X instead of N, I'm good with that.
Wait, I think I did it wrong. I got 20.
Yeah, what's wrong? Remember, you're adding up 25 terms.
Oh, yeah.
Right?
You're right.
You're going to have to add up, that's what this is saying. You got to have 25 terms here. Yep, it should be 2,400, right?
So then do we divide it by 25 and then we get 180? Oh, wait, no. Wait.
That's the answer.
I'm adding up all these terms from 12 to 180. So if I wrote them if I wrote out all 25 terms and added them up, it would add up to 2,400.
Yeah, I just forgot what the question is.
Okay, yep. So anytime I ask you to add up numbers in an arithmetic sequence, we have to build our own sigma. The bottom is always 1. You got to do a little work, obviously, to find what goes here. And then to find how many terms we're adding up, you can guess and check, I guess, or just plug in the term at the end. 1 doesn't make you great. I know you're hungry for more. Here's 8. Ooh. So what do we know here? What am I giving you here? I know I got an arithmetic sequence. How many terms are there? What am I? Any of these values up here, what's it mean to you? Any of them? There's 19 terms. All right, so hey, you can get the top and bottom done right now. N equals 1, 2, 19. There's 19 terms. That's what that N tells me. Hey, isn't that what we just solved for here? N equals 25. There's 25 terms. So that N value tells you, right, how many terms are in the sequence. What else do you know?
Or any term is 154.
Not just any term. We already know what N is, right? 19. So get more specific. What term is the 154th? The 19th term, right? Because if N's equal to 19, that N matches that one. So it says the 19th term is 154. And what are we going by? By 8, right? So the only thing we're missing is what? Well, is that formula, right? That's the only thing we're missing. And where do I get that formula from? We made it up twice already today. Where do I get that formula from? Where do I find that nth term formula? By using what's on the formula sheet. Okay, so do it with me. Ready? Let's go back.
Are we plugging in 154?
Nope. Not yet. All right. N stays N, right? N stays N. Oh, we ran into a problem. I need what to do this? I need the first term. Okay, so I need somehow to generate the first term so I can plug it in and write my formula and go to my calculator. Oh, great. I don't have the first term. Is there any? I need it though. I can't just skip it. Is there any way I could find the first term maybe? What's thoughts, Emma?
Don't we already know the common difference?
We do. Is 8. So what do you suggest?
Subtract by 8.
The common difference means add 8 every time, right? Well, what if I wanted to go backwards? I could subtract 8. Now look, that's going to take a little bit of time, right? Keep subtracting 8, subtract, because I'm on the 19th term. It's going to take a while to get back to the first, right? You could do that. Okay. We could do that, right? Or we could just keep using this formula. Watch. I'll get back to that in a second. I'll get back to that one in a second. What's this usually mean? Any term. Do we know any term, which is what? 154 is equal to, we're trying to find what that is, the first term. Where's 154 spot in the sequence? 19 minus 1, and what's my d value? 8. So now I can use this formula to solve for the first term, then go back to what I need. So go ahead, 19 minus 1 times 8, move it over. Anybody find that first term? Should be less than 154, that's for sure. 10?
Yeah.
Okay, so it's 10. Now go back up and write my nth term now. 10 plus, oh, maybe not. You kidding me? Good timing. Good, go back up, plug in 10. What are you going to plug in for n? Don't even say it. What are you plugging in for n? Nothing, n. Leave it, minus 1, and what's our d value?
8.
Times 8. I'll get back to it in a second, so we can do a little visual here. Of course. So a sub n equals, what did we say was our first term, 10? Plus n minus 1 times 8. Go ahead, distribute the 8. Okay, what am I putting to the right of this sigma here? N equals 1 to 19, and then, what is that, 2 plus 8n? And then you're on calc duty now.
Mr. Curly,
Yep, go ahead.
this is a stupid question.
No, it's not. Don't ever
It's
say
not really
that.
a question. Well, I guess. Didn't you just do like 18 times 8 and then get 144 and then just subtract that from 144 instead of doing like the whole equation?
Yeah, that's what if you notice what we did, what did we say? 154 equals A1 plus, what did we say? 19 minus 1.
Yeah. Didn't you just say,
Yeah, that's what we did. Yeah.
So,
You don't have to, do you have to show this? No.
okay,
but we're
so
doing-
I don't even have
We're
to show
doing
that.
exactly what you just told me.
Okay.
Yeah.
So I could really just
Yes.
write. Okay.
Okay. I just want you to know we're doing the same thing.
Okay.
We're just showing
But
it
I don't have
differently.
to show, like, on a
No.
test if I didn't show that.
No. However you get the job done. Yes. Max,
How do we get n equals 1?
how did I get what? N equals?
1.
That's always a given. You always, because anything I'm showing you here, it doesn't work if you start with another number. Okay? got to be n equals 1. And what do we end up here with? What's the sum here? 1 to 19. Calculators.
1,558.
1,558. Okay, we good? All right, look, I really should have gotten rid of number 9 because I'm going against everything I stand for when I show you this, how to do this solution. All right, great. They run a marathon every year. Matt's training. He runs 20 miles the first week. Each week he increases it by 4. How many total miles does he do in 8 weeks? I wouldn't do this if I were you. I wouldn't do this. I just told who was it? Harper. Whatever gets the job done. How many miles did I run in the first week?
20.
How about the next week? Just list. It's only 8 weeks. List it out and add them. Okay, list it out and add them. I don't need anything fancy here. All right, I'm not going to require you do a sigma every time. All right, so we might as well just do it easiest way, right? Save ourselves frustration. Next week, 28, right? 32, 36, 40. What am I up to? 1, 2, 3, 4, 5, 6, 7, 8. It's 8 weeks. You know, now if I said 50 weeks, all right, we got a different ball game, but if it just said 8 weeks, just why not? Just do it out by hand here. Let's not waste our sigma time here. And what do we got? 272 miles of running. Yep. And before we end it here today, just let you know, because I'm moving on to the next topic tomorrow. 9 questions, 24 points on Thursday, and it's these 3 topics we've been going over. Okay? Recursive, arithmetic, and the series we just went today. And also, hold up, places to practice. I put a review for the quiz on Delta Math, and then today's assignment out of the textbook would be good too. All right, again, I'm not reviewing tomorrow. I'll show this again at the beginning, but we're moving on. So if you guys have any questions for today's assignment, which is out of the textbook, you let me know tomorrow. All right, sorry I took it the whole time, which is very rare in here, but it happened today. All right. So beginning of class tomorrow, I'll take any questions about the quiz, and then I'm moving on.